This next example is the distance formula. I know you guys have seen this one before as well. Distance equals rate times time. That's what those letters represent, rate and time. So for this one, we want to solve for the r. We want to get the r by itself. Notice that it's being multiplied by t. So to get rid of that t, I need to divide both sides by t. Now here, there's only one piece that it's being multiplied by, so I'm just dividing by the one piece. I'm left with the rate. The rate is equal to the distance divided by your time, t divided by t. So we're going to leave it just like that. The previous one, we had it multiplied by two pieces at the same time. We had to divide by both of them. Here, we've got only one piece that we have to divide by. Just look to see how many things are stuck together with that variable that we're trying to isolate. The next one is the density formula. D equals m over v. This is one that you've probably seen in science before too. To get the v by itself, or to get the m by itself, I can manipulate this equation. Now, I'll tell you guys that regardless of which one I do by itself first, I really want you guys to notice that we've got a fraction equation here. So the very first thing we have to do, regardless of which variable I'm getting by itself, is I need to clear the fraction. So I'm going to multiply both sides by that denominator of the fraction v. So I'm going to write dv is equal to, and here my v's are going to cancel, so just the m. Now when I want to get the v by itself, I realize that now I have to divide both sides by d. So v should equal our m divided by d. Notice, guys, that on this one I couldn't just get the v by itself right away and say, oh, it's being divided, or I'm taking m and I'm dividing by v. I can't just multiply by an m. That's not exactly what this looks like. I first always need to clear a fraction if you notice that there's a fraction in the problem. So for this one, I said d is equal to m over v. I still would need to clear the fraction. And notice that I would have dv, and again, you could put them in any order. I could have said vd also. But dv is equal to rm. Now on this one, I'm done because that's all I needed to do is solve for m. So there, I'm already good to go. Make sure when they tell you which variable to solve for, just make sure that in your answer, that variable is what's by itself, that you've isolated that variable. Okay, for this next one, it's another one where we're just solving for y. We want to get this y by itself. Notice that on the same side of the y is this negative 2x. Negative 2x right now, to remove that, I need to add a 2x. I'm doing its opposite operation. Whatever I do to one side, I have to do to the other side. So I'm left with y is equal to 2x plus 8. Or I could have said 8 plus 2x. The order that you put those terms will not matter. Now, I've already solved for the y. I've gotten the y all the way by itself. Your answer could look like that, or again, it could be 8 plus 2x. Either one of those would be perfectly okay. For the next one, again, we're solving for y. I'm going to give you guys a second. I want you to think about this on your own. What's on the same side as y? How do I remove it? Hopefully you guys realize that this negative 2x is on the same side of the y. So to remove it, I want to add 2x. But whatever I do to one side, I have to do to the other side. So y is equal to, and again, you could say 5 plus 2x or 2x plus 5. Either one of those would be wonderful, and I will not be super picky yet as to what we do. In the future, if you want to try to start to get into a habit, we will want to always put the piece that has the variable, we want to list that piece first. So make sure that you start to get in that habit. This next piece, we're solving again for y, but notice that we have some distribution that we're going to have to do. So in this case, we're going to distribute first. We're going to take 2 times our y and 2 times our 3. So 2y plus 6 is equal to our 2x. We again want to get the y by itself. Notice there are 2 things on that side of the equation that we need to remove. First, we need to remove the 6 because that's just added or subtracted. The 2 is what's being multiplied. That coefficient, the thing that's being multiplied by the variable, is the very last thing that we will undo. So let's go ahead and let's subtract our 6 from both sides. We're removing the 6. I'm left with 2y. And again, the order, I won't be super picky yet, but we'll try to get in the habit of putting the variable part first. So 2x minus 6. Now, looking at what we have left, we still have this 2 that's being multiplied by our y. We need to divide to get rid of that 2. Since it's being multiplied, we need to divide to get rid of it. But I have to do it to both sides of my equal sign. 2 divided by 2 cancel. It gives me just 1y. And it's equal to, well, this 2 divided by 2 is also just a 1x. But negative 6 divided by 2 will give me a negative 3. So y will equal our x minus 3. This next one, we have another fraction. So to clear that fraction, I'm going to multiply each piece in that equation by the denominator of our fraction, which was a 2. Here, the 2's are going to cancel. I'm left with just 1y. You could say just 1y, or you could just write y. 2 times our negative 5 is going to give us a negative 10. But negative 3x times 2 is going to give us a negative 6x. Now, we've gotten rid of the fraction. Our goal is to get this y by itself. So I know I need to remove this negative 10 from the side. So I'm going to go ahead and add a 10 to both sides of my equation. The negative 10 and positive 10 are going to cancel. So I'm left with 1y, or you could even just say y. And it's equal to, we had a negative 6x plus 10. Notice that the y is already by itself, so that's as much as we needed to do. For the last problem, notice that we've got, again, another equation. We're trying to solve for y. There's no fractions or anything weird. We need to get rid of this 3, though, to get the y by itself. Right now, it's a positive 3, so to remove it, I need to subtract 3 from both sides. The 3's are going to cancel. I'm left with just the negative y, and it's equal to, I have a 9x and a negative 3. They're not like terms. I can't combine them. Just 9x minus 3. The y is almost by itself, but I still need to get rid of that negative 1. So I'm going to divide both sides by negative 1, each piece. And I'm left with y, and a positive divided by a negative is going to give me a negative 9x. And our negative divided by our other negative is going to give me a positive 3. So y will equal a negative 9x plus 3. All right, as you guys work on your homework today, I really want you to think about just isolating the variable. Undo whatever operation you currently see next to that variable. Always move pieces that are added or subtracted first. The last thing you're going to move or remove will be that multiplication piece. If you have a fraction, you know how to clear fractions. Just make sure you do that to every single term. All right, guys, do your best, and I will see you tomorrow.